Before getting his PhD in biology from NAU, Matt O'Neill wanted to be either a fighter pilot or marine biologist. While working on a fishing boat in Alaska, his decision was made.
I was on a longliner, and so I was on the deck of a longline boat, and a giant halibut came up on the line. I remember it coming partially out of the water, and its mouth opened up, and I could put my head into its mouth without touching the teeth on either side of its jaws. So it's a huge, huge fish. And so that was what really sparked my interest in functional morphology and feeding morphology.
Studying how fish survive and feed in the rivers and streams of Arizona is just one of the many facets of his job as manager of the Arizona Game and Fish Department's Aquatic Research and Conservation Center in Cornville.
This facility is a major component in the recovery plans for two critically endangered species. The loach minnow and the spike dace are two small-bodied minnows. They were both spread across most of the state historically, and now loach minnow are down to, hopefully they're down to 8 extant populations, and spike dace are down to 3.
In addition to providing a refuge for native species, the facility also breeds fish for repatriation efforts. They are then used to replenish rivers and streams in the event of catastrophic loss from fire or drought.
So if there's a wildfire, if there's a drawing of the stream with the drought, if that wild genetic lineage goes extinct, all the new fish that create new populations come from this facility. So these are spike dace from the Gila River, and they are one of the groups that is susceptible to wildfire. So this is one of 3 extant populations. And so they're spawning in this tank, and so they'll be spawning on the substrate down below here, and their larvae get washed down into a tank down here, and we collect the babies and stock them into new creeks.
Matt's colleague, Clinton Moran, studies the differences in native fishes' hydrodynamics, physiology, and body shape to determine the best ways to manage their habitats.
And my research focuses on looking at those slight differences and seeing if there's a performance enhancement with those slight differences. So with the machine behind me, we look at the swimming speed of these fish based on small morphological differences or small differences in body shape. Those minor morphological differences in the fish account for very vast performance changes. So understanding the underlying mechanics and metabolic requirements that these fish need is essential to properly managing these fish.
Matt credits NAU with giving him the skills to contribute to a vital area in Arizona's wildlife conservation efforts, as well as providing him the tools needed to succeed in other managerial areas.
Working with people at NAU and working with people outside of NAU throughout my degrees really helped me learn how to develop the professional and personal relationships that help make this kind of job function. And so my experience at NAU really helped me with those skills.